Hi friends, this is Sujeevana, belongs to CSCA section of Adishankara Institute of Technology. Today I am here to explain addressing modes in computer organization and architecture. First of all, what is addressing modes? The operation field of an instruction specifies the operation to be performed. This operation must be executed on some data stored in the computer registers or memory words. The way the operands are chosen during program execution is dependent on the addressing mode of the instruction. The addressing mode specifies a rule for interpreting or modifying the address field of the instruction, and the operand is actually referenced. Program counter. It is also known as PC value. The program counter register keeps track of the instructions in the program stored in the memory. PC holds the address of the instruction to be executed next and is incremented each time an instruction is fetched from memory. Now, example, here we can see the program counter value, and this is the corresponding register value, and this is the index value, and this is the accumulator value. Now, types of addressing modes. The first addressing mode is implied addressing mode. In this mode, the operands are specified implicitly in the definition of the instruction itself. It means the operand is not specified explicitly. It is not necessary to overshow the operand. For example, the instruction complement accumulator, that is CMA, is an implied mode instruction because the operand in the accumulator register is implied in the definition itself. There is no need of special specification. The second one is direct addressing mode. In this direct addressing mode, the instruction contains the effective address. If we go for the effective address, we can find the required operand. Here address is equal to 500 is the effective address. Now this 500 is the effective address. Now if we go for this 500, we can find the required operand. This is the accumulator content. Now it is the address of the data to be used, address of the operand. Effective address is 500 and the operand to be loaded into the accumulator is 800. Now the third one is indirect addressing mode. In this, it is the address of the data to be used. Now the instruction contains the address of the effective address. It means the address of the effective address is 500. If we go for this 500, we can find the effective address. Now 800 is the effective address. If we go for 800, finally we will get the required operand. Effective address is 800 and the operand is 300. Register mode. In this register mode, the corresponding register contains the content of the accumulator. It means 400 itself is the required operand. Register indirect mode. In this indirect mode, the corresponding register contains the address of the operand. Here the address of the operand is 400. If we go for 400, we can find the required operand. So 400 is the effective address and 700 is the operand. Immediate mode. In this, operand is specified in the instruction itself. It has an operand field rather than the address field. Operand field contains the actual operand to be used in conjunction with the operation specified in the instruction. The second part of the instruction is taken as an operand rather than an address. So 500 is loaded into AC. It means here in the immediate mode, this is the instruction place. In this immediate mode, the instruction place is replaced by the operand. We there is no need of effective address or address. Directly this 500 is the operand, required operand. Auto increment mode. This is similar to register indirect mode except the register is incremented after its value is used by the access memory. Here the corresponding register value is 400. So let's go for 400. Here it is the address of the operand, this 400. Now if we go inside 400, here we can see 700. This is the required operand. As the name specifies auto increment mode, here the post incrementation takes place. Once this register value is used, that means this 400 is used, this is incremented by 1. So the register value becomes 401 and the operand is 700. Auto decrement mode. As the name specifies decrement mode, but here post decrement doesn't happen, pre-decrement happens. Let us see. Here the R1 value, the corresponding register value is 400. First it is decremented by 1. So the register value is 399. If we go, this is the effective address. 399 is the effective address. If we go for 399, here we can find the value of the operand. So the value of the operand is 450, which is to be loaded into the accumulator. Relative addressing mode. In this mode, the content of PC is added to the address part of the instruction in order to obtain the effective address. It means we will have a PC address. As in the first slide we discussed, the PC value increases one by one after the instruction is executed. Now the PC value is 202 because the next instruction is about to happen. So the address value is 500 and the PC value is 202. If we add these 500 and 202, we will get the effective address as 702. If we go for 702, we will find the operand. We will find this operand. This is the value that to be loaded into the accumulator. The value is 325. Once again, the address value is 500 and the PC value is 202. If we add these address and the PC value, we'll get the effective address. If we go for the effective address, we'll find the operand. Index addressing mode. This is similar to relation addressing mode, but in this mode, the index register is added to the address part of the instruction to obtain the effective address. Here the index value is 100 and the address value is 500. If we add these 100 and 500, we will get the effective address as 600. Once we get inside the 600, we can have 900 as the accumulator content. Now this 900 is known as operand. Base register addressing mode. In this mode, the content of base register is added to the address part of the instruction to obtain the effective address. This is similar to the indexed addressing mode. The difference between the two modes is in the way they are used rather than in the way they are computed. An index register is assumed to hold an index number that is relative to the address part of the instruction. A base register is assumed to hold a base address and the address field of the instruction. Thank you. Hope you will have understood.